You outlined 5 branches of vitamin D resistance. Which subtype, genetic, organ damage, toxin, drug, or gene silencing, is currently the most underdiagnosed, yet clinically significant in your opinion?
I'd like to say there's 2. It depends on your age. Okay, so you roughly have about 1 million nephrons in each kidney. Those are the filtration units. So at age 20, you've got most of the ones that you'll ever have in your life. Those are progressively lost with age. And so decreased kidney function, 85% of your calcitriol, that's the kidney metabolite, the most active form of vitamin D hormone, that's generated in the kidney. And so as you age, when you start having a significant drop in your what's called GFR, glomerular filtration rate, now that kidney deficit is dominant because that's your main source of it. Now, you're younger, okay, I would say drug-induced vitamin D resistance. Okay, so people are taking certain steroids, dexamethasone, or Paxlovid in the case of COVID. And there's a paper, and it's listed in my talk from 2020, Common Drugs as Vitamin D Disruptors. And they're talking about disruption of calcifediol and calcitriol biosynthesis. So if you're interested in whether a drug that you're using or prescribing might be a vitamin D disruptor, take a look at that paper. But the way to test that is that Mayo test called the 24-25D test. That looks for the hydroxylation at the 24 carbon position. I know I'm talking numbers and letters, but that's what you need to do. You need to start thinking about the specific sites of hydroxylation, whether it makes the molecule active, hormone, or inactivated, ready for excretion. And the Mayo test will allow you to see in a patient, it examines this key metabolite, it's the 24 hydroxylation of calcifediol that they're looking at. That test has not been available before. One of the members of the LDN Research Trust 6 years ago, when I met him, he started using it. And he started identifying Epstein-Barr reactivation. And how it ties in, that's still uncertain. People are now taking tenofovir as a means of attenuating Epstein-Barr reactivation. And you're seeing this in long COVID patients. So I'm suspicious that tenofovir might be a vitamin D, a quote, vitamin disruptor. I hate that term because I'm saying it's not the inactive vitamin D metabolite that we take, it's calcifediol and calcitriol which are being disrupted. But not to discount what's happening in long COVID. There's damage to the kidneys, but it's damage to small diameter capillaries everywhere, the brain, the gut. And so malabsorption of vitamin D3 in the gut, that could be a increasing prevalence. So whatever age, whether it's pediatric or middle age, old age, we're seeing massive amounts of recurring gut infections. And this probably been going on for quite some time. So organ injury, gut and kidney, add those to the list. They may be increasingly prevalent in different age groups.
There's actually this is a question about your presentation yesterday, Sebastian, but always welcome. Your contribution to maybe in his presentation, Sebastian referred to a variety of opioid receptors which are concentrated in very different areas of the body. Are there expected healthy ratios that change with the disease? And if so, are there tools to be able to assess these versus expectations?
I understand the question is that we do see different expression of those opioid receptors at different times, especially if you've got different disease states. And so we can also see that with certain cancers being expressed. And so we don't have that insight, or I haven't seen it yet, of specific ratios or specific patterns. But we do know that there is different expression types. And so that is an upcoming research paper that bright person is probably already exploring and seeing if I read it. So if we have that paper, that'd be super handy, but I don't know as of yet.
When you're talking about pain and receptors, they're not only expressed in different locations, they have different functions, right? And so, as an example, since we just watched the documentary, in hypermobility, this is going to take away my cool point for tomorrow, but in hypermobility, we express a fair amount of NMDA receptors, which are different than sort of opioid receptors and phenyloid receptors, et cetera, in the myofascia and in the joints. And so when you have hypermobility and altered movement and altered proprioceptive response, those signals get crossed in the periphery and generate more pain into the signaling of the central nervous system. And that's different than some of the other receptors that are chemo-responsive or heat-responsive, et cetera. It depends a little bit on the condition, and it depends a little bit on how they're interacting, because ultimately, that's where you have to break the cycle and identify that and the source of that.
So you had asked about opioid receptors, but if you were talking about pain receptors, you see the AMPA receptor complex also upregulating before NMDA activation and expression. And so, yeah, we do know that there's regulatory aspects to all these different disease states and that you do see these expressions. But again, I can't speak to specifically pain, but ratios of those receptors. When you see an upregulation in a pain pattern, it's very different and it's very unique. I'm sure that you probably see this in immune cells because you see TLR expression upregulated in response to deficits or hyperactivation, because it's now like, how do we handle all this incoming information? We better upregulate.